Six Sigma, FMEA, and POCA-YOK. Now we're going to continue in the analyze and improve phases by discussing two important risk reduction tools, FMEA and POCA-YOK. FMEA stands for Failure Modes and Effects Analysis. It helps us identify where a process, product, or system could fail before that failure reaches the customer. POCA-YOK means mistake proofing or error proofing. It is a way to design the process so errors are either prevented from happening or detected immediately. These two tools work very well together. FMEA helps us identify and prioritize risk. POCA-YOK helps us reduce that risk through practical controls. FMEA Intro. FMEA stands for Failure Modes and Effects Analysis. It is a structured tool used in Lean Six Sigma to identify potential problems, assess their impact, understand their causes, and prioritize which risks to address first. The important word here is potential. FMEA is proactive. We are not waiting for a failure to happen. We are asking, how could this process fail, and what can we do before that failure reaches the customer? An FMEA typically looks at each step in a process and asks, what could go wrong? What would happen if it went wrong? Why might it happen? How serious would it be? How often might it happen? How likely are we to catch it before it causes harm? This makes FMEA especially useful in manufacturing, where small process failures can lead to scrap, rework, safety issues, downtime, customer complaints, or warranty problems. Severity, occurrence, detection, and RPN. In an FMEA, we commonly score each risk using three ratings: severity, occurrence, and detection. Severity, or S, asks, how bad is the outcome if the failure happens? This is usually scored on a 1 to 10 scale, where higher numbers mean more serious impact. Occurrence, or O, asks, how likely is the failure to happen? Again, this is usually scored on a 1 to 10 scale, where higher numbers mean it is more likely to occur. Detection, or D, asks, how likely are we to catch the failure before it reaches the customer or causes harm? This one can feel a little backwards. A low detection score is better because it means we are likely to detect the issue. A high detection score means the failure may escape. These three numbers are multiplied together. Severity times occurrence times detection equals the risk priority number, or RPN. The higher the RPN, the more urgently the team should consider addressing that risk. For example, if a form is not submitted, the effect might be a missed deadline. If the cause is unclear instructions and the severity is 8, occurrence is 7, and detection is 5, then the RPN is 280. That gives the team a way to compare risks and decide where to focus first. One important caution: the goal is not to debate scores forever. The goal is to prioritize risk and take action. FMEA and DMAIC. FMEA is commonly used in the analyze and improve phases of DMAIC. In the analyze phase, FMEA helps us understand where failures could occur, what causes them, and which ones create the greatest risk. In the improve phase, FMEA helps us decide what controls or improvements should be implemented to reduce that risk. FMEA can help reduce errors and defects. It can improve safety and reliability. It can save time and resources by preventing failures rather than reacting to them after they happen. That is the key mindset shift. Instead of asking, how do we fix this after it breaks? FMEA asks, how can we prevent this from breaking in the first place? Failure Mode and Effects Analysis. What is FMEA? FMEA is a structured, proactive method for identifying and prioritizing risk. It evaluates how a process or product could fail, what the impact of that failure would be, and how the team can prevent or control it. FMEA shifts teams from reacting to problems to preventing them. This is especially important because not all failures matter equally. Some failures may be minor inconveniences. Others may create major customer dissatisfaction, safety risks, production stoppages, regulatory problems, or expensive rework. FMEA helps us focus on the highest risk failures first. In manufacturing, where processes are often complex and customer expectations are tight, this type of structured risk analysis is extremely valuable. Why FMEA matters in manufacturing. Manufacturing processes often involve many inputs, many handoffs, and many opportunities for error. There may be tight tolerances, complex assemblies, specialized equipment, multiple operators, supplier inputs, inspection points, and customer-specific requirements. Because of that complexity, We need a way to identify risk before it turns into defects. FMEA helps teams prevent defects before production or launch. It helps reduce scrap, downtime, and customer complaints. It also helps protect CTQs, or critical to quality characteristics. Remember, CTQs are the characteristics the customer truly cares about. If a failure mode affects a CTQ, it deserves serious attention. The purpose of FMEA is not to eliminate every possible risk at any cost. The purpose is to focus resources on the risks that matter most. The core FMEA questions. For each process or product step, FMEA asks 3 core questions. First, how could this fail? That is the failure mode. Second, what happens if it fails? That is the effect. Third, why would it fail? That is the cause. After that, we evaluate the risk by asking, how serious is it? How often might it occur? How likely are we to detect it before it escapes? These questions help us move from vague concern to structured analysis. Instead of saying, this step seems risky, we define the specific way it could fail, the consequence of that failure, the reason it might happen, and the strength of our current controls. Key FMEA elements. Let's define 3 key FMEA elements: failure mode, effect, and cause. The failure mode is the specific way a process or product could fail. For example, hole drilled oversize. The effect is the consequence of that failure. For example, the part will not assemble, which could cause a line stoppage. The cause is the reason the failure occurs. For example, tool wear, incorrect offset, or setup error. These 3 elements need to be specific. If the failure mode is too broad, the team will struggle to identify meaningful controls. If the effect is unclear, the severity score may not reflect the real customer or process impact. If the cause is vague, the improvement action may not actually reduce risk. A strong FMEA depends on clear thinking and clear wording. Risk evaluation, severity, occurrence, detection. Each failure mode is rated on severity, occurrence, and detection. Severity asks how serious the effect is. Occurrence asks how likely the failure is to happen. Detection asks how likely we are to catch the failure before escape. These ratings are used to prioritize risk and decide where to act first. The goal is not perfect scoring. Different people may score risks slightly differently, and that is okay. The discussion is often as valuable as the number. The real goal is to build a shared understanding of risk. If a failure has high severity, high occurrence, and poor detection, then it should clearly move toward the top of the priority list. The team can then decide whether to reduce occurrence, improve detection, or, ideally, prevent the failure from happening in the first place. Process FMEA versus Design FMEA. There are 2 common types of FMEA: Design FMEA and Process FMEA. A Design FMEA, or DFMEA, focuses on product design risks. It asks, how could the design fail to meet requirements? DFMEA is usually used during design and development. It is often owned mainly by engineering. Inputs may include drawings, specifications, customer requirements, material selections, and design assumptions. DFMEA can drive design changes, tolerance changes, material changes, or other design improvements. A Process FMEA, or PFMEA, focuses on manufacturing and assembly risks. It asks, how could the process fail to make the design correctly? PFMEA is usually used during process planning and production. It is often owned by manufacturing, operations, or quality teams. Inputs may include process flows, work instructions, control plans, tooling, fixtures, and inspection methods. PFMEA can drive process controls, inspections, POCA-yoke devices, SPC, setup controls, and operator training. The goal is the same for both types: reduce risk and protect the customer. A simple way to remember the difference is this: DFMEA reduces risk by improving the design. PFMEA reduces risk by controlling how the design is built. Both work together to protect CTQs and customer expectations. POCA-yoke, error proofing. Now let's shift into POCA-yoke. POCA-yoke is a Japanese term commonly translated as mistake proofing or error proofing. The idea is to design a process so it is difficult or impossible to make an error, or so the error is detected immediately before it moves forward. POCA-yoke is powerful because it recognizes that people make mistakes. Instead of blaming people for human error, we design the process to help prevent errors. Examples might include a fixture that only allows a part to be loaded in the correct orientation, a connector that can only be plugged in one way, a sensor that stops a machine if a part is missing, or a checklist that prevents a critical step from being skipped. The best Poka-yoke solutions are simple, practical, and built into the process. Poka-yoke, mistake proofing. Poka-yoke can work in two main ways. The first is prevention. A prevention Poka-yoke makes it impossible, or nearly impossible, to make the mistake. For example, a fixture may be designed so a part cannot be placed backwards. The second is detection. A detection Poka-yoke identifies that something is wrong before the defect escapes. For example, a sensor may detect that a component is missing and stop the process. Prevention is usually stronger than detection because it stops the error from happening in the first place. But detection is still valuable if prevention is not practical. In Lean Six Sigma, we prefer controls that are built into the process rather than controls that depend only on memory, attention, or inspection after the fact. Poka-yoke helps reduce defects by making the right way the easy way and the wrong way difficult or impossible. Poka-yoke at FastCap. This slide references Poka-yoke at FastCap. FastCap is often used as an example of a company that emphasizes continuous improvement and practical lean thinking. The important lesson from examples like FastCap is that mistake proofing does not always have to be complex or expensive. Many effective Poka-yoke ideas are simple. They may involve labels, color coding, shadow boards, physical stops, templates, fixtures, checklists, visual cues, or layout changes. The best ideas often come from the people closest to the work because they understand where mistakes actually happen. When we combine FMEA and Poka-yoke, we get a strong improvement approach. FMEA helps us identify the highest risk failure modes. Poka-yoke helps us prevent or detect those failures in the process. That connection is especially useful in the improve phase. Make sure to watch the linked video. Think about a process you know well. Where are errors most likely to occur? What would happen if those errors escaped? How severe would the impact be? How often do they happen? How likely are you to catch them before they affect the customer? Now think about how you could mistake-proof the process. Could a part be physically prevented from being installed the wrong way? Could a checklist prevent a missed step? Could a sensor detect a missing component? Could color coding, labeling, or visual management reduce confusion? Could the process be designed so the correct action is obvious? That is the mindset behind FMEA and Poka-yoke. To summarize, FMEA is a structured way to identify and prioritize risk. It helps teams understand potential failure modes, effects, causes, and current controls. Severity, occurrence, and detection help prioritize which risks deserve attention first. Poka-yoke helps reduce risk by preventing mistakes or detecting them immediately. Together, these tools move us from reacting to failures to preventing them. As we continue through Lean Six Sigma, remember that strong improvement is not just about fixing problems after they happen. It is about designing processes that make success more likely and failure less likely.